Hello everyone. Myself Mr. S.M. Ghanwat, working as Assistant Professor, Mechanical Department at Sharad Institute of Technology, College of Engineering, Yadra. In this session, we are going to discuss Introduction to Material Science and Engineering. The content that we are going to cover is why to study material science and engineering, what is material science and material engineering, the four components of the discipline of material science and engineering and their interrelationship with example and classification of material. Now we will start with the actual session. Why to study material? Materials are everywhere. Consider any field of engineering, you will find the material. Many applied scientists or engineers, whether mechanical, civil, chemical, or electrical, will be exposed to a design problem involving material. Examples might include a transmission gear, the superstructure for building, an oil refinery component, or an integrated circuit chip. Of course, material scientists and engineers are specialists who are totally involved in the investigation and design of materials. Many times, a materials problem is one of selecting the right material from the thousands that are available. The final decision is normally based on several criteria. First of all, the in-service conditions must be characterized. For these, will dictate the properties required for the material. On only rare occasions, a material possesses the maximum or ideal combination of properties. The classic example involves strength and ductility. Normally, a material having high strength will have only limited ductility. In such cases, a reasonable compromise between two or more properties may be necessary. A second selection consideration is any deterioration of material properties that may occurring during service operation. For example, significant reductions in mechanical strength may result from exposure to elevated temperatures or corrosive environments. Finally, probably the overriding consideration is that of economics. What will be the finished product cost? A material may be found that has the ideal set of properties but is prohibitively expensive. Here again, some compromise is inevitable. The cost of finished piece also includes any expense incurred during fabrication to produce the desired shape. Therefore, an engineer or scientist is more familiar with the various characteristics and structure property relationship as well as processing techniques of material. Therefore, it is important to study each and every material that is available in a market, and also by studying all these materials it is possible to determine the strength and weaknesses that we are going to identify and again that are utilized in different applications to carry out the performance. Now we will proceed further. Materials are probably more deep-seated in our culture than most of us realize. Transportation, housing, clothing, communication, recreation, and food production. Virtually every segment of our everyday lives is influenced to one degree or another by materials. Sometimes it is useful to subdivide the discipline of material science and engineering into material science and materials engineering subdisciplines. Strictly speaking, material science involves investigating the relationship that exists between the structure and property of material. Means we are going to investigate the relationship between structure and property is nothing but the material science. And in contrast, material engineering is on the basis of these structure property correlations designing or engineering the structure of a material to produce a predetermined set of properties. Means what we are going to do, we are going to have the structure property correlation, and based on this correlation we are going to design or engineering the structure of a material to produce a predetermined set of properties in nothing but materials engineering. From a functional perspective, the role of material scientist is to develop or synthesize new material, whereas a material engineer is called upon to create new product or system using existing material and or to develop technique for processing materials. Now we will proceed with the next point. The next point is structure. Structure of a material usually relates to the arrangement of its internal components. Means how internal components are arranged, based on that the structure of material is going to reveal. Accordingly, we have subatomic structure, which involves electrons within the individual atoms and interaction with the nuclei. The next is atomic level structure, which encompasses the organization of atoms or molecules relative to one another. Next, microscopic structure, which contains large group of atoms that are normally agglomerated together. Next, macroscopic, which is viewable with the naked eye. Once again, we will repeat all these. We are going to define the structure as a material usually relates to the arrangement of its internal components, how internal components are arranged accordingly. You have the structure of the material. The subatomic structure involves electrons within the atoms and interaction with their nuclei. Atomic level structure encompasses the organization of atoms or molecules relative to one another. In microscopic structure, it contains large group of atoms that are normally agglomerated together, and microscopic structure, which is viewable with the naked eye. Now we will move further with the next point. Our next point is the property. Again, the property is one of the important component of science and engineering of materials. The concept of property deserves elaboration. While in service use, all materials are exposed to external stimuli that evoke some type of response. Means for consider for a application, I am utilizing a material. Then under service use, definitely it is exposed to some external stimuli, because of which you will get the certain response. For example, a specimen subjected to forces will definitely experience the deformation. Means under service condition, when I am going to apply certain amount of force on the material, definitely it will experience the deformation. Or the next example is a polished metal surface will reflect the light. It is the next example of the property. Now, a property is a material trait in terms of the kind and magnitude of response to a specific imposed stimulus. Generally, definitions of properties are made independent of material shape and size. Now, virtually all important properties of solid materials may be grouped into six different categories. First is mechanical, second is electrical, third is thermal, fourth is magnetic, fifth is optical, and sixth is deteriorative. Now we are going to elaborate each property. For each property, there is a characteristics type of stimulus capable of provoking different responses. We will start with the mechanical property. It relates deformation to an applied load or force. Examples include elastic modulus, we call it as stiffness, strength, and toughness. Now, for electrical properties such as electrical conductivity and dielectric constant, the stimulus is an electrical field. The thermal behavior of solid can be represented in terms of heat capacity and thermal conductivity. Now, magnetic properties demonstrate the response of material to application of magnetic field. For optical properties, the stimulus is electromagnetic or light radiation, index of refraction, and reflectivity are representative optical properties. Finally, deteriorative characteristics or property relates to chemical reactivity of materials. All these properties are more important to analyze the material, and based on these properties you will get the performance at the application level. Therefore, all these properties plays an important role when you are going to use the material at service use or at the application end. And once again, we'll repeat all these properties one by one. Mechanical properties, in which the important point is elastic modulus, strength, stiffness. For electrical properties, stimulus is electrical field. Thermal, thermal conductivity or heat capacity. For magnetic property, magnetic field is there. For optical properties, index of refraction, reflectivity is there. And for deteriorative characteristics, it is based on chemical reactivity of material. Now we are going to discuss the four components of the discipline of material science and engineering and their interrelationship. The four components are processing, structure, properties, and performance. Now we are going to discuss these four components with example. In addition to structure and properties, two other important components are involved in the science and engineering of materials, namely processing and performance. With regards to the relationship of these four components, the structure of a material will depend on how it is processed. Means the processing technique or technology that you are going to utilize to process the component, based on that it is possible to determine the structure of that particular material is nothing but the structure of material, and basically it depends upon how it is processed. Furthermore, a material's performance will be the function of its properties. Based on the properties assigned to the given material, based on that properties, it is going to give the performance at the application end. And based on that performance, the material is utilized for the service conditions. Therefore, the properties also plays an important role to provide the certain amount of performance of the material in application and or service conditions. We now present an example of these processing structure properties performance principles with figure, a photograph showing three thin disk specimens placed over some printed matter. It is obvious that the optical properties, that is, the light transmittance of each of the three materials are different. The one on the left is transparent, that is, virtually all of the reflected light passes through it, whereas the disk in the center and on the right are respectively translucent and opaque. All of these specimens are of the same material, aluminum oxide, but the leftmost one is what we call a single crystal, that is, has high degree of perfection, which gives rise to its transparency. The center one is composed of numerous and very small single crystals that are all connected. The boundaries between these small crystals scatter a portion of light reflected from the printed page, which makes this material optically translucent. Finally, the specimen on the right is composed not only of many small interconnected crystals but also of a large number of very small pores or void spaces. These pores also effectively scatter the reflected light and render this material opaque. Thus, the structure of these three specimens are different in terms of crystal boundaries and pores, which affect the optical transmittance property. Furthermore, each material was produced using a different processing technique, and of course, if optical transmittance is an important parameter relative to the ultimate in service application, the performance of each material will be different. This is the example which will explain you the four components of material science and engineering. In this example, it is possible to find the relationship between these four components. With regards to the relationship of these four components, the structure of a material will depend on how it is processed, and furthermore, a material's performance will be a function of properties. These are the relationship between these four components. For further reading, you can refer Material Science and Engineering An Introduction by William D. Callister and David G. Rethwich. In next session, we are going to cover classification of material.